Hello viewers, in today's session we are going to discuss another important problem from derivatives, and here we are going to differentiate this function f of x which is equal to sine inverse, and here we have square root of 1 plus x raised to n plus square root of 1 minus x raised to n divided by 2, right? So here we have to find out the derivative of f of x with respect to x. Now here to get the derivative of f of x, we'll make use of the method of substitution to simplify this function by introducing another variable, right? So let us start. So here let us substitute this term, that is x raised to n equal to cosine of theta, right? So we'll make this substitution to simplify this expression, and x raised to n is equal to cosine theta. So now this function f of x is now equal to sine inverse, and here we have a square root of 1 plus x raised to n. X raised to n can be replaced by cosine theta. Then here we have 1 minus cos theta. Again x raised to n is replaced by cosine theta, and here we have 2, right? So now here we'll make use of some trigonometry, and from trigonometry we know that 1 plus cosine theta is equal to 2 times cos square theta over 2, and similarly 1 minus cosine theta is equal to 2 times sine square theta over 2. So these are the two important half angle formulas. So here we have now sine inverse and square root of 1 plus cosine theta, and 1 plus cos theta is replaced by 2 cos square theta over 2, and here we have square root of 2 sine square theta over 2. So replacing 1 minus cosine theta by 2 sine square theta over 2, and in the denominator we have 2. So now we can write sine inverse, and here we have square root of 2 and cos square theta by 2. It can be taken outside the square root sign, so we have simply cosine theta by 2. So this square get cancelled with this square root, and similar is the case here. We have square root of 2 and sine theta over 2 divided by 2, right? Okay, so now let us take this term as square root of 2 over 2 cosine theta over 2, that is distributing this 2 over this term and this term, so that we can write this entire term as a sum of two expressions. So the first one is the square root of 2 over 2 cos theta over 2, then we have square root of 2 over 2 sine theta over 2, right? Now square root of 2 over 2 is equal to 1 over square root of 2. So now we have sine inverse, and here we have 1 over square root of 2 cos theta over 2 plus 1 over square root of 2 sine theta over 2. So now let us replace this term, that is 1 over square root of 2 by sine pi by 4, because sine 45 degrees is 1 over square root of 2, and this term can be replaced by cosine pi by 4, that is 1 over square root of 2, right? So now we can write sine inverse, and 1 over square root of 2 is sine pi by 4, and here we have cos theta over 2, and then 1 over square root of 2 can be written as cos pi by 4. Here we have sine theta over 2, right? So now we have this expression in which we can assume pi by 4 as alpha. So alpha is pi by 4, and beta can be taken as theta over 2. So we have sine alpha cosine beta plus here we have cosine alpha, and then we have sine beta, right? So this is the well-known sum formula, angle sum formula for sine function. So we have sine of alpha plus beta, right? So sine pi by 4 cos theta by 2 plus cos pi by 4 sine theta by 2 is equal to sine alpha plus beta, where alpha is pi by 4, beta is theta by 2. So we have sine pi by 4 plus theta by 2, right? So now this expression is equal to sine inverse, and here we have sine pi by 4 plus theta by 2, right? So this expression is equal to sine pi by 4 plus theta by 2. So here we have sine inverse sine pi by 4 plus theta by 2. So now these two get cancelled, or from inverse trigonometric functions we can use the concept of principal value branch. So we have these two get cancelled. So we have pi by 4 plus theta by 2, right? So now our function f of x is equal to pi by 4 plus theta by 2. So f of x is now equal to pi by 4 plus theta over 2, right? Now let us replace this theta by cos inverse x raised to n, because when x raised to n is equal to cosine theta, then theta is equal to cos inverse x raised to n. So let us replace this theta by this expression over here. So we have f of x is pi by 4 plus half cosine inverse x raised to n, right? So this is the simplified form of this expression using this substitution. So now we have to find out the derivative of f of x with respect to x. So let us differentiate f of x with respect to x. So we have d by dx of pi by 4 plus half cos inverse x raised to n. Now pi by 4 is a constant, and the derivative of a constant is 0. So now we have simply d by dx of half cos inverse x raised to n. Taking half outside this operator, we have d by dx of cos inverse x raised to n, right? So now we have to find the derivative of cosine inverse x raised to n. So here I will make use of this result, that is the derivative of cos inverse theta is minus 1 over square root of 1 minus theta square, right? So here for theta we can take x raised to n. So we have half, then we have minus 1 over square root of 1 minus theta square. Theta is x raised to n square, and then by chain rule we have to find the derivative of x raised to n. So now simplifying this, we have minus 1 over 2 times square root of 1 minus x raised to 2n, and then the derivative of x raised to n with respect to x is nx n minus 1, right? So we can write now minus n x raised to n minus 1 over 2 times square root of 1 minus x raised to 2n. So this is the derivative of f of x, where this f of x is equal to this function, and the derivative is given by this expression. So let us discuss one special case here. Suppose we have n is equal to say 4, right? So when n is equal to 4, then the function f of x, it assumes the form sine inverse square root of 1 plus x raised to 4 plus square root of 1 minus x raised to 4 over 2, right? And the derivative of this function f of x, that is f prime of x, is given by substituting n is equal to 4 in this expression. So we have minus 4, then we have x raised to 4 minus 1, then we have 2 times the square root of 1 minus x raised to 2 times 4. So here we have 2 times 2, 4. So this is minus 2 x raised to 3, and here we have square root of 1 minus x raised to 8. So 2 times 4 is 8. So the derivative of this function f of x when n is equal to 4 is minus 2x cube divided by square root of 1 minus x raised to 8. And similarly, we can discuss other cases also. Hello viewers, in today's session we are going to discuss another important problem from derivatives, right? And here we are going to solve a problem related to derivatives in which we are going to use the concept of composition of functions, right? So let us first read out this problem. Here we are given three functions f of x, that is equal to square root of x square plus 2, g of x, x over x square plus 1, and h of x is minus x plus 5, right? And here we have to find the value of this expression, that is f double prime, and here we have h prime of g prime of x, right? So we have to find the second derivative of f of x when the input is h prime of g prime of x, right? So this problem also includes the concept of composition of functions. So let us see how we can solve this problem. So here let us first find out the second derivative of f of x, right? See, here we have f of double prime of h prime of g prime of x. So let us first find the first derivative of f of x. So f prime of x is given by d by dx of square root of x square plus 2, and this expression can be differentiated like this, that is half, then we have square root of x square plus 2, and then by chain rule we have the derivative of x square plus 2, right? So first we have here applied this power rule, that is d by dx of x raised to n is nx n minus 1. So we have x square plus 2 raised to half, and first we have taken half, then x square plus 2 raised to half minus 1, and then by chain rule we'll find the derivative of x square plus 2, right? So when we simplify this expression, we'll get 1 over 2 times square root of x square plus 2. So we have half, this is x square plus 2, and the derivative of x square plus 2 is 2x. 2 and 2 get cancelled, so we are left with x over square root of x square plus 2. So now let us find out the second derivative. So f double prime of x is given by d by dx of x over square root of x square plus 2, and here we'll make use of the quotient rule. If we have two functions, say u and v, and these two functions are functions of x, so we have v du over dx, then we have u dv over dx divided by square of v. So here this function can be taken as u, this function can be taken as v. So we have x, here we have x square plus 2 times we have the derivative of x, then we have x derivative of here we can write d by dx of x square plus 2, and then here we have the square of x square, square root of x square plus 2. So now we have square root of x square plus 2 because the derivative of x with respect to x is 1, and here we have x, and the derivative of square root of x square plus 2 is given by x over square root of x square plus 2 divided by the square of square root of x square plus 2. So here this the power half is cancelled with this 2, so we have simply x square plus 2, right? So here we can take the LCM and we can simplify this expression like this, that is f double prime of x is given by we can multiply these two quantities, so we are left with only x square plus 2, and then we have minus x square divided by square root of x square plus 2 times x square plus 2, right? So now we have this x square and this x square get cancelled. So we are left with 2 over square plus x square plus 2 raised to half plus 1s, because here the power is 1 and here the power is half. So half plus 1 is 3 by 2. So here we have 3 by 2. So we have obtained the value of f double prime of x as 2 over x square plus 3 2 raised to 3 by 2. So now let us find out the derivative of g of x, that is the g prime of x. So we have g prime of x is equal to d by dx of gx, and gx is given by x over x square plus 1. And here again we can apply the quotient rule. This is u and this is v. So we have x square plus 1, then we have derivative of x, then we have x and derivative of x square plus 1, and divided by x square plus 1 square. So the derivative of x is 1, so we have x square plus 1 times 1 minus x times 2x. The derivative of x square is 2x, derivative of 1 is 0 being a constant, and here we have x square plus 1 square. So this is x square plus 1 minus 2x square. This is x square plus 1 square, and here we can write 1 minus x square over x square plus 1 square, right? So viewers, the derivative of this function g of x is given by this expression, that is 1 minus x square over x square plus 1 whole square. So now let us find out the derivative of the third function, that is h of x is equal to minus x plus 5. So this is a linear function. So h prime of x is given by d by dx of h of x, and this is d by dx of minus x plus 5, and the derivative of x is 1, so we have minus 1, right? And the derivative of 5 is 0 being a constant. So h prime of x is equal to minus 1, and here we can see that h prime of x is a function which is a constant function, right? So h prime of x is equal to minus 1 for all values of x in the given domain, right? So whatever be the value of x in the given domain, h prime of x is always equal to minus 1. And this is the important thing in this problem, because see, we have to find f double prime and h prime of g prime of x. So now if we substitute here g prime of x, then we have 1 minus x square over x square plus 1 square. And now see, here we have h prime of this function. So here our input is now 1 minus x square over x square plus 1 whole square, right? So h prime of x is equal to minus 1. So whatever be the value of x in the given domain, h prime of x is always going to be minus 1. So here if we take this function as input, then we have h prime of for x we can now write 1 minus x square over x square plus 1 square is equal to minus 1. So for this input, h prime of this function is equal to minus 1, right? So now this expression is now equal to f double prime, and h prime of this function is equal to minus 1. So here we have minus 1, right? So now we have to find the value of f double prime of minus 1. So now f double prime of minus 1 can be obtained by replacing this x by minus 1. So when we take x is equal to minus 1 over here, we'll get the value of f double prime of minus 1, that is equal to 2 divided by we have minus 1 square, because x is equal to minus 1, and here we have 2 raised to 3 by 2. So this is 2, and here minus 1 square is 1. So we have 1 plus 2, that is 3. So this is 3 raised to 3 by 2. And we can now write 3 raised to 3 by 2 as 27 raised to 1 over 2. So now the square root of 27 is equal to 3 times square root of 3. So now here we have 2 over 3 times square root of 3. So viewers, the value of this expression when we have these three functions is equal to 2 divided by 3 times square root of 3. So this is how by using all these concepts we can easily solve these kind of problems related to derivatives.